Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi there folks, and welcome to the Azure AI Fundamentals course, a course all about the fundamentals of artificial intelligence, and today we'll also look at some of the services in Microsoft Azure around AI. Now, if you are unfamiliar about Azure and unfamiliar about the cloud in general, I would also recommend you to do the AZ900 course, the Azure Fundamentals course. That is a course all about the cloud. What is the cloud? What is our service in the cloud? What's the power of the cloud? Why should we use the cloud? Overall, a great course if you're completely new to the cloud. Today we'll focus more on artificial intelligence. Who am I? I'm Tigo. I'm from the Netherlands. I'm a former data scientist for Microsoft and these days a Azure technical trainer. My hobbies are trying to make beer, it's not going well, and playing Dungeons and Dragons. So at least you know who's in front of you. So let's start. Today will be a one-day course. We'll have some hands-on experiences for you to try things out, and you can find those at docs.microsoft.com/learn. And I encourage you to follow these modules there as well, and take a little bit more of a deeper dive. I would even say that today, looking at me is like a course lecture. When you're studying, you have lectures, and going to the docs side is like a course in a textbook. So they supplement each other. I have to say though, today might be a little bit too short to completely transform you into the data scientist. But at least you'll get a broad understanding of all the technologies and what there is, right? So what is there today? We'll have 5 modules. We'll start with an introduction of artificial intelligence. What is artificial intelligence? What are sort of some of the workloads or examples of artificial intelligence? And we'll talk, which is very important, we'll talk about responsible AI. More on that later. In module 2, we'll talk about machine learning. What is machine learning? What are some of the broad topics in machine learning? So in this case, we'll talk about 3 different types of algorithms, namely regression, classification, and clustering. A little bit of math, but don't worry, nothing complicated. And after we've introduced you to AI and machine learning, we'll get into these 3 broad topics. It is computer vision, understand, how computers understand the world around them visually. We'll talk about natural language processing, understanding, written or spoken text. And last but not least, conversational AI, really bots that use AI to create conversation. So those are the 5 topics, and that will also be our agenda for today. So let's get started with module 1. In this module, we're going to look at the introduction to artificial intelligence, and we're going to focus on the definition of artificial intelligence. What is artificial intelligence? We're going to look at some of the common workloads of artificial intelligence, and we're going to look at artificial intelligence in Azure. Second part of this module will be about responsible AI. Really, what are the challenges and risks with artificial intelligence? And folks, I have a statistics background, and some of my courses already were about responsible AI. And I think it's a very important topic these days. So stay tuned for that part. And we'll also take a look at some of the principles of responsible AI. And the principles of responsible AI are a set of principles, and at Microsoft here, our AI software development is guided by these set of principles. So let's start with our first lesson, artificial intelligence in Azure. And, ask yourself, what is artificial intelligence? What is the definition? And if you go to a search machine, use Bing or Google, you will find a lot of different definitions. Every link has its own definition. Every professor has its own definition. And I didn't make up one myself for now, so I'll just quote an American professor here. And he said that artificial intelligence is the science and engineering of making computers behave in ways that, until recently, we thought required human intelligence. So think about that, folks. Until recently, we thought that it would require human intelligence, and now we no longer think this, right? It's mimicking our behaviors. And a great example here would be, self-driving cars, right? 20 years ago, we never thought that would be even possible. And here it is. It is software that is imitating our human capabilities. So let's look at some other examples here, right? Some other examples of imitating human capabilities. It is making decisions based on data and past experiences. And this is already super interesting because it needs data. It needs experiences to learn and how it should make these decisions. And we'll talk more about this today because I think that's a fundamental principle. Because what if it gets the wrong data? Think about it, folks, and we'll get back to that later. Recognizing abnormal events. It imitates our human capabilities. We have, or we can, intuitively know when something isn't just quite right or just doesn't fit this expected pattern. Now, software can take this over from us. Interpreting visual input. Of course, we use sight to experience the world visually, and now computers use cameras to do the same. Understanding written and spoken language. Yes, this is common for us, right? We communicate by writing and speaking, and now software imitates this behavior. Engaging in dialogues in conversation. Yes, conversational AI. Normally we are, always we are able to engage in dynamic conversations and responding appropriately. And now, software also takes us over. So really, it's a lot of human capabilities that can now be taken over by software up to a certain extent, of course. Now, let's look at some of the workloads. So, of course, we have machine learning workloads, and we have a different set of workloads: anomaly detection, computer vision, natural language processing, and conversational AI. And you might, on the exam, get a question around identifying these types of AI workloads. So let's look at them individually, and we'll explore each of them in detail later, right? We'll get a separate module on them. Let's start with machine learning. Predictive models based on data and statistics, and really the foundation for AI. Okay, that's true. An example here will be if I have a bike rental shop, and I'm trying to rent out bicycles. It's great, and I notice that when the temperature is higher, I tend to rent out more bicycles, but I want to know it for sure. And in this case, I can have a machine learning model to try to predict, based on the temperature, try to predict how many bikes I'm going to rent out that day. Really basic. It's going to be probably a fairly simple model, but we'll look at that more in this in the upcoming modules. Anomaly detection, detecting unusual patterns of behaviors. And one thing I should note here that it is mainly about detecting something that is very rare in the data. And a good example here is credit card fraud, or if a network might be hacked. And on the credit card example here, because I think that's a fun example. If you buy a credit card, sometimes, or if you have a very unpredictable travel schema, sometimes you also get flagged as a potential fraud attempt. Because normally, if you have, supposedly you're in my country, Netherlands, and you use your credit card, and in the same minute, someone in, Australia used this as well. That is strange. And the algorithm will probably say like, uh-oh, something is going wrong. I'm blocking the credit card. So the person in Australia, tries to use the credit card and it just says, no can do. Well, sometimes this goes wrong because now you're just bought a new credit card and you're just going on a holiday and then you use the credit card and then it says, nope, will not work. Again, algorithms are not perfect. They also just do their best, but they are as good as the data they're getting and they're not 100% accurate. So sometimes they make a mistake. So that's really anomaly detection. Computer vision, what are some of the workloads? Face recognition, distance detection on driving cars, but let's make it a little bit interesting. Violence detection, not just detecting people on a camera, but detecting people and then a certain set of behaviors that gets classified as violence. So a little bit more complicated, but very, very interesting. Natural language processing. Some of the workloads here will be the spell check, the spam filter on your email, the voice assistant because you're talking to it and it needs to process the language. And this is interesting because it overlaps with conversational AI, right? The bots that engage in dialogues. And this is also a great example here would also be the voice assistant. So you see overlap. Let's even, if you're looking at an entire solution, there's even more overlap. Let's take an example. Imagine you have a conversational AI solution that uses a bot to process an auto insurance claim. And this bot then relies on some natural language processing capabilities to make sense of inputs such as, I want to submit a claim. It may allow even users to send a photograph of the damaged vehicle because they were in a car crash. And then the program then uses computer vision to assess the damage. And then it might even also apply a machine learning model to predict the amount of repair costs associated with it. And then finally, the bot could be using some form of anomaly detection to identify potentially fraudulent claims. So in this entire solution, it uses a lot of different workloads. Let's take a look at why should we be using the cloud for this? And the reason is actually quite simple. Because Microsoft Azure, the cloud, our cloud, can offer three things here. The first one is data storage, because the cloud can offer an almost unlimited amount of data storage. Now, while your own laptop, you might have a couple of, maybe a terabyte, but that's about it. Then next up is compute. Now, training a simple model is only, maybe a second. But if the algorithms itself become more complicated, like maybe violence detection or distance detection, really these neural networks, that can take a lot of time to train, especially on a laptop. And I'm not talking about weeks here, folks. And with this massive amount of compute available in the cloud, you can reduce these computation times to, minutes even. And the third argument here will be services. Because, in Azure, we have three services. The first one is Azure Machine Learning, which is a cloud-based service to build, test, deploy, predictive analytics solutions. The second one is Cognitive Services, which is a set of AI capabilities that are available through a list of APIs. Where you don't need any form of machine learning experience whatsoever. You can just use it, and I'll demo this. I'll demo this later. And we have the Azure Bot Service, which is a framework for building conversational AI solutions. That, for instance, could help on a website or automatically respond to emails. And with that, I would like to, for those who are still unfamiliar with the cloud and unfamiliar with our Azure portal, which is one way of using the cloud, let me just show you, give you a quick demo here. So I have opened up a browser and let me just quickly go to portal.azure.com. So I'm typing it in, .azure.com. Luckily there's auto completion for me here. I'm pressing enter and the portal will load. Now with my credentials already has me logged in, so it will immediately open the portal for me. And here I am. I'm in this main screen. I see some of my recent resources and I see at the top, I see some of our Azure services. On the top right hand, let's start there. I already saw a small notification that I have some money on my subscription available that is still remaining, 25 euros remaining. Okay, so that's good to know. And I have some settings here as well. Of course, an often asked question is, can I choose the theme of the portal? And yes, that is possible. If you want to have it a darker theme instead, you can opt for this, and you see it has an immediate effect here. But for the sake of this demo, we'll stay with a lighter theme because it's a little bit more easy to read. Now, I could also change the language or region here, and those are just some of the general settings. Also in the top right, I could leave some feedback if I'm happy with something or not satisfied with something, and we like feedback. So if you have anything, if you're playing around in the portal, don't forget, give us some feedback here. So that's just the general options there. And if I go to the top left, the little hamburger menu here, that is a flyout panel. And as soon as I click here, it will open up. Now I see some of my favorite resources, and I can also click on all services or even a dashboard. But that's a little bit too in-depth for now. Let me just show you that I can even add and remove things to my favorites here. So I can see here on the center services here, I see a machine learning. And if I hover over it, I can see there's a little star at the top right. I click the star, and with that, when I now go to this flyout panel again, I can see that at the bottom here, there is machine learning, which I can even drag up until here and ta-da. So that's really something you should do, because if you're working a lot with the same resources, it's easier to just add them to your favorites. Another thing that I would like to point out is that as soon as you're hovering over, it brings out this menu, and you can immediately already see that it will give you some free trainings, some learning paths available to easily start using these products. So once you are connected, you have an Azure subscription, connect to the portal, and if you don't know what to do, just hover over some of the services, and we'll immediately provide you with some great resources to start learning. Well, I think that's great. And later in this course, we'll show you on how to create an Azure Machine Learning workspace. But for now, I just wanted to show you quickly around the basics of the Azure portal. So with that, let's go back. So I gave you a small demo of the Azure portal. And with that, I would like to continue with our second lesson, which is responsible AI. Because when we're talking about developing AI, we should think about responsible AI, and we should discuss this. And we should look at the challenges and risks that come with artificial intelligence. And we listed 6 here, and let's go through them. Bias can affect result, right? A lone approver model discriminates by gender due to bias in the data with which it was trained. And for those who don't know what bias is where the expected value of the result differ from the true underlying parameter being estimated. So there's a difference in the result. It shows you something, but the truth is actually different. And I like silly examples, so let's make up a silly example here. Supposedly I have 50 people, and they all make apple pies, and they're good and bad at making apple pies, and I rate that as good or bad. And now I want to try to find relationships, so I hand out questionnaires and I interview them, and I train a model. And the model is trained, and it can perfectly predict whether someone can make apple pies or not. So, well, on the first sight, I am happy. And then I look at the relationships, because it apparently is so that in the data that I have and in the algorithm, the most important predictor for being good or bad at making apple pies was left or right-handedness. And then I think to myself, like, well, wait a minute. Is that true? Is it really true that being left-handed then makes you better at making apple pies? Right? Or should this be a case of bias? And then I look at the data, because remember, the model is only as good as the data it gets. And then I see that although I made nice groups of men and women, so I had men and women in the group that was bad at making apple pies, and I had men and women in the group that were good at making apple pies. But I forgot about also distributing being left and right-handedness. Being left or right-handed. And then it turns out that I only had left-handed people who were good at making apple pies, and I only had right-handed people who were bad at making apple pies. So it makes sense that then the model thinks like, oh, well, that is apparently, there's a relationship between those. But in reality, is it true? Might not be the case, right? So this is a form of bias. And you can counteract this by making sure that the data is distributed, accordingly. Okay, so it really can affect results. Second one is errors may cause harm. Yes, an autonomous vehicle, if it experiences a system failure, what happens, right? That it could be it could cause a collision, and it can be very serious. Another example here would be if there's an algorithm that determines whether or not you have a certain disease. And if you have the disease, you should be operated immediately. What if there's a wrong diagnosis based on the algorithm? So it could cause harm, right? Because a certain operation can be very invasive. Data could be exposed. Yes, because you should protect your data. The example here is that a medical diagnostic bot is trained using sensitive patient data, which is stored insecurely. That is a risk, right? A risk for personal data. And the fourth one, solutions may not work for everyone. No, indeed. If you do not think about it, that might be the case. And the example here is a predictive app provides no audio output for visually impaired users. But you should think about these things. Users must trust a complex system. Yeah. An AI-based financial tool makes investment recommendations. What are they based on? Because computers usually do not explain their predictions, right? This explainability, that's a problem. We have some solutions for this. They are too in-depth for this course, as Shapely, Lime, but we do have to take care of this because you would like to have an explanation why it's making this decision, right? And the last one, who is liable for AI-driven decisions? If there's an innocent person convicted of a crime based on evidence from facial recognition, who's responsible? Because again, an algorithm is not perfect. It makes mistakes. Maybe it's 90% accurate. Is that enough? Or is it not enough? Who makes those decisions? Really some challenges and risks around AI. And with your peers, have a discussion around these topics. What are your opinions, and how do you think you should tackle these challenges? Next up, we have the principles of responsible AI, because when we at Microsoft, when we develop AI software, we are guided by these 6 principles. And the first one is fairness, because yes, all systems should treat people fairly. It shouldn't, let's make up an example here. Suppose you have a loan approval application for a bank. The model should make predictions of whether or not the loan should be approved without incorporating any bias based on gender, ethnicity, or you name it, any other factor, right? Because it might result in an unfair advantage or disadvantage to a specific group. Luckily, Azure Machine Learning includes capability to interpret models and quantify the extent to which each feature of the data influences the model prediction. Right, so you can look at each feature and see, okay, what does it do? What effect does it have on the outcome? Reliability and safety, yes, because AI systems should perform reliable and safe. If there's an AI-based software system for an autonomous vehicle, well, you can guess the problem, right? If it's unreliable, it can result in substantial risk to human life. That's why AI-based software development must be subjected to rigorous testing to ensure that it works as expected before it gets released. Let's move on. Privacy and security. Yes, AI systems should be secure, should respect privacy, right? Because sometimes, to train a model, it needs large volumes of data that might contain personal details, and they should be kept private. But even after the model is trained and the system is in production, it uses new data to make those predictions or take actions, right? So again, there is this it's being fed new data, and also that has to be secured. Inclusiveness, yes. All systems, all AI systems should empower everyone and engage people. AI should bring benefits to all people of society, right? Regardless of physical ability, gender, sexual orientation, ethnicity, or any other factor. It should empower everyone. Transparency. All systems, AI systems, should be understandable. You should be made fully aware of the purpose of the system, how it works, what are the limitations that may be expected. And last but not least, accountability, because people should be held accountable for AI systems, right? If there is a problem with this autonomous vehicle, who is responsible? And that's why designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensure that the solution itself meets ethical and legal standards that are clearly defined. So really just 6 of these principles. And again, it's great, discuss along with your peers, among your peers, who, if an autonomous vehicle has an accident, who is responsible? Is it the person that was driving the car, or is it the data scientist that developed the model, or is it the manager of the data scientist who agreed that if the model was 99% accurate instead of 99.9, it was okay to put it in production? And with that, let's move on to our lab. In this lab, we're going to look at some cards. We have different decks of cards, and we're going to review some example scenarios. And inside those example scenarios, we can identify some responsible AI principles. So I'm going to flip a few cards, but you can do it yourself at home as well at aka.ms/hci-demo. I've already opened the link inside my browser, so let's go there right away. Here we are, and indeed you can see at the bottom different decks of cards. So let's pick the first one here, and it says, make clear how well the system can do what it can do. And on the right side of that, there are some examples. So in this case, you have the Office new campaign experience. There is the word ideas, and there is the word preview. And this gives you, that helps you with setting expectations about the presented suggestions. Another example here would be Apple Music. And Apple Music will say, we think you'll like, when it's suggesting you new music. And this gives some form of uncertainty. And with that, it makes clear how well the system can do what it can do. Let's pick another card. Let's take a red one here. Mitigate social biases. In the example in practice here, you see that there is a calendar, and below the calendar is an icon of a person. And this icon has been made gender neutral, so there is no bias on gender. Let's take another example here. Bing. So when searching for CEO or doctor, it shows you images, but it shows you a diverse set of images in terms of gender and ethnicity. And another example of mitigating social biases is when you're typing something in the Android keyboard, and it suggests both genders when you're starting to type with an H, because it can either be him or her. Okay, so let's take another card here. Let's just take this one. Make clear why the system did what it did. And we're looking here at the example about Office Online. It recommends documents to you where other people have been working on, and there is a description above it that makes it clear why the recommendation is shown. Another example here would be, let's see, Amazon.com, because there is a why recommended session, and it shows you the products in your history that create the recommendations that you get. And another example here, let's see, Facebook, yes, because it gives you an explanation. Why are you seeing this ad in the newsfeed? So again, making clear why the system did what it did. Let's go to another card. Let's see, let's pick, let's pick somewhere in the middle here. Encourage granular feedback. Yes. So in this case, in Excel, you have ideas, and then at the end, it will ask you, is this helpful? So you can give it feedback. Another example here, Instagram. You can hide specific ads, but then it will ask you, okay, why why don't you want to see this ad? What are the reasons behind it? Because it wants to understand why the ad is not relevant. And another example here, you see in Apple's Music, you see a love or dislike button. Both are easily accessible, they're quite prominent, and with that you can easily give some feedback back. Okay, so I would recommend going through the cards yourself at home and maybe discuss these with your peers. Now, if you want to know more, you want to learn more, and especially when you're pursuing some certification, I would advise you to also go to the learning paths at aka.ms/learn artificial intelligence. I've already opened up a browser tab with this, so let me just show you. Here we are. It will redirect you to this page. Get started with artificial intelligence on Azure. It's 27 minutes long, and it's a learning path, only one module, and it will actually also just guide you introductory through all the modules. And just an introduction to AI, understand machine learning, and these topics, right, which we already discussed. Anomaly detection, computer vision, natural language processing, conversational AI, and responsible AI. So again, if you want to know a little bit more and pursuing this certification, would definitely recommend going through these. So in this module, we covered the following concepts. We looked at what is artificial intelligence, what are some of the common artificial intelligence workloads, right? I talked about the violence detection, spelling checker, and numerous other things. And we've taken a look at artificial intelligence inside Azure. And in the second part of this module, we took a look at the challenges and risks with AI. Remember the bias. And we went through these 6 principles of responsible AI. And with that, let's get started with module 2. In this module, we'll be looking at machine learning. And we'll start, of course, by just an introduction to machine learning. And we'll look at these 3 types of algorithms, which is regression, classification, and clustering. And after that, we'll take a look at the Azure machine learning, what it is, and we'll take a look at the designer and automated machine learning, which we call AutoML. And well, I'll just demo that and I'll show you around in the portal, and we'll train a model in the designer, and we'll train a model using the automated machine learning. But first, just what is machine learning? And the goal here again is not to teach you linear algebra. It's just to help you gain an intuition on how machine learning works. So, what is machine learning? Machine learning is creating predictive models by finding relationships in data. Now, suppose I'm a botanist. I'm actually not a botanist, but the example is kind of funny. Suppose I'm a botanist and I just collect flowers. And each of these flowers, they have features such as the measurement of petals or stem or any other kind of details, color, you name it. Now I can provide a label, right, for these flowers. So I'm doing this, and you can see here I provided some labels. So on top left you can see 2 flowers, and I labeled those Bellus perennis, and the top right I named them Rosa multiflora. Now this sample data I can now process using an algorithm, and I can combine this together, and this algorithm now is going to find the relationships between the features and the labels. And after it has done this, I can now use this algorithm to predict new flowers. So in this case, I get a new flower, and my algorithm will predict then that it's probably a Bellus perennis. Really simple basics of machine learning. No math yet. Okay, so let's start with the first type of algorithms, which is regression. And regression is the most common technique, actually, where you want to predict a numeric value, like a price, sales total, or, well, you name it. And for this example, we're going to look at bike rentals. So before we can even train an algorithm, I need some data. So here it is. I have the temperature and the amount of rentals. It's in Fahrenheit, the temperature, so it's not in an oven. And you can see that at 56 degrees, I rented out 150 bicycles. And at the bottom of the chart, you can see that at 80 degrees, I rented out 154 bicycles. So already just looking at the data, it seems that when the temperature go up, my bike rentals might go up as well. So the thing I'm trying to predict here is the Y, is the bike rentals, and we're calling this Y, and the feature is the temperature, and I'm calling this X. Now, I'm not going to put this entire data set into a model because I want to test it as well. So what I'm going to do is split it up. Splitting it up in a training set and a validation set. I'm going to use the training set to train a model, and I'm going to use the validation set to validate the model. Now, in a real life example, because this is only a few rows, so in a real life example, it would be more data. I would, probably my validation set would be about 20 to 30% of my data. Now, so I have splitted my data, and let's plot it. I'm plotting the temperature on the horizontal axis and the bike rentals on the vertical axis. And here you can already see that there appears to be some kind of relationship. And I could even, plot a line through this, right? Because I'm trying to find some kind of function. So, plotting a line to it, and there is you can see the trend, and there's a couple of things that are interesting, because the point where the line intersects the vertical axis is around 35, and the slope of the line, well, it looks to be around. For every 1 increase in temperature, it looks to go up for about 1.5 bike rentals, right? It looks about right. So I have 35 as a baseline, and the slope is 1.5. Now, I can create a function out of this, and that would be this function. So this is all the math, folks. Don't be scared. So this is actually my algorithm already, right? Because the function over the temperature, and I can use that. So 35 plus 1.5 times the temperature will be my bike rentals. So let's test it, right? Because now I have my function, and we can test it with the validation data that we held back. And that is not called, those predictions that I'm going to make are not called Y, but they're going to called Y hat. So they have a little hat on top of it. And you can see here that for a temperature of 54 degrees, my actual bike rentals were 114, and my predicted bike rentals were 116. So there's a little bit of difference. And now you can see how well the model predicts by measuring the difference between the predicted values and the actual values that we know to be true. And this tells us the amount of error in the model. And there are various ways to calculate this error and generate some common metrics that we can use to evaluate a regression model. Now, if I plot the predictions here on the graph, and indeed you can see that there is a little bit of error because they're not perfect. But again, perfection doesn't really exist. And this is just this error. Okay, that is a really basic example of regression. And regression is another form of supervised machine learning. And supervised machine learning is when you have data that has a known label value. So in the case of the regression, I knew the amount of bike rentals already. I had that data. And in this case, for classification, we're going to look at diabetes. And I already have some data here with outcome variables. And after classification, we'll take a look at unsupervised machine learning. So for now, we have some data, including some features and a label. And the label here is the Y, whether a person has diabetes or not. And the features are some medical measurements like weight, height, blood pressure, and so on. Now, the label here is 1 or 0. So 0 means not having diabetes, and a 1 means having diabetes. And the algorithm we're going to use will predict a number between 1 and 0. So it is a probability. And we'll take a cutoff value of 0.5 to determine whether a person has or does not have diabetes. But first, let's do the same as with regression. We're going to split the data up into a training set and a validation set. Training set to train our algorithm, and a validation set to validate the algorithm. We're also going to plot these values on a line. Horizontal axis, we've plotted the features, and the vertical axis, we plotted the y, the outcome variable, or whether a person does or does not have diabetes. And again, like I said, we're taking this cutoff value of 0.5. We're plotting a line through the values, same as that we did with the regression, with the linear regression, but this time we're not putting a straight line to it. It's a logistic function. Okay, so we have that. Now let's look at our validation set. Again, we have a little bit of validation set, and we plot again the values on this line. Now, looking at this plot, you can see a couple of things. The top value here, the top blue circle, is pretty certain that that person has diabetes. Same goes for the person at the bottom. It's pretty certain that that person does not have diabetes. However, the two values in the middle are very close to this threshold. So maybe they're wrong, right? Because there's a lot of uncertainty around this. The top maybe has like a 53% certainty that the person has diabetes, and the other person has a little bit below this 50. Now, using the algorithm, we're gonna make predictions, and we're gonna the probabilities. And for the first row, we have a probability that a person has diabetes of 0.2, and the probability that a person does not have diabetes as 0.8. And that is this bottom blue circle here. Let me just point it out with a little laser pointer here that it's this one, right? Because the probability is very low that this person has diabetes. And also the prediction, the y-hat, predicted that this person does not have diabetes. So this is truly negative. And that's also what we're calling it true negative. Okay, so let's look at the other one, the second row. In this case, the person has diabetes, and the probability that the person has diabetes is 0.9. And indeed, it gets correctly classified as having diabetes. And this one here is the top value here, and indeed it is a person has diabetes. We call this a true positive. Now, here it becomes interesting, because if we're looking at the data, you can see that this person does not have diabetes, but the probability of him having diabetes is estimated at 0.6, and he gets wrongly predicted as having diabetes. And this is now a false positive. And the other one is the other way around. It gets falsely accused of not having diabetes while it actually has diabetes, and that is a false negative. So it gets falsely put into the negative bracket. Now, again, if we're putting this in a little table, let's do this right away. True positive, false positives, false negatives, and true negative. So top left, true positive, and bottom right, true negative. Now we can compute some metrics with this. Now 4 rows is it's just not enough. So what we're going to do is we're going to add some data. And with this, with a magical touch, poof, we have more data. And now you can see that there's 126 true positives and 119 true negatives. And only a few false positives and false negatives. So, so it seems to be a very decent model. I'll color those to make it a little bit easier. Now, like I said, I can calculate metrics with this. So what I can do is I could calculate accuracy, which is the proportion of true results among the total number of cases. And I could calculate the precision. What proportion of predicted positives is truly positive? But let's stick with accuracy, right? So just the true results among the total number of results. I can calculate this. So let's do this. 126, you can see it top right here, 126 plus 119 divided by the total. And this brings me to a 0.897. So that's about a 90% accuracy. Now, when accuracy is not always useful, I'll give you the following example. What if I'm trying to predict meteor crash in 1,000 days. So every time I sample, and most of the time, of course, there is no meteor crash, but just once there is a meteor crash. And when I now, train the algorithm, it will give me great results. It will give me a great accuracy, but it's not doing anything, right? Because I'm unable to predict this one-time meteor, but my accuracy will be awesome, because the total amount of true negatives is very high compared to the total amount of cases. So this is an example of where accuracy as a metric is not really useful. Now, that's classification, another form of supervised learning. And let's look at an example of unsupervised learning. Let's look at an example of clustering. And the example of unsupervised learning is that we do not have the outcome variable. We don't know. So in this case, in this example here for clustering, we're using flowers, and we have the length of the flower and we have the number of petals of the flower. Remember the example I gave you before we went to regression, right? Then we labeled the flowers, but now we don't have this labeling. So we're going to try to find clusters. How are we going to do this? Well, let's first put it on a two-dimensional plot. Now, on a horizontal axis and on a vertical axis, I'm going to place the length of the flower and the number of petals. Next up, I'm going to decide how many groups do I want to find. And I determine I want to find 3 groups, and that is called K. So I'm going to find 3 groups, and I'm going to place 3 data points randomly on this grid. And I'm going to call those centroids. And then I'm going to determine which are the nearest flowers of these centroids based on the mean distance. Let's make it a little bit more colorful, and here it is. So I found the nearest flowers. Next up, as this cluster algorithm is doing, is I'm going to place the centroids in the middle of the flowers it found. So here it is. Now it is nicely in the middle. And then again, I'm going to find the nearest flowers based on the mean distance. So let's see what happens now. Aha, okay. New thing. Again, placing the centroids in the center, and again, and again, and again. And this iterative process repeats itself until, it stabilizes. And let's show that. And here we go. Now we see we found 3 groups, and we adjusted the centroids based on the mean distance. Now, this clustering algorithm is called K-means clustering. And that is a simple example of clustering. And with that, let's go to our second lesson of this module. And in this lesson, we'll be talking about Azure machine learning. And what is Azure machine learning? And we'll look at the automated machine learning, and we'll look at the designer. But first, start at what is Azure machine learning? Well, simply said, it is a cloud-based platform for machine learning. And to use Azure machine learning, you'll need an Azure subscription. Otherwise, you won't be able to use anything. And in that subscription, you can create an Azure machine learning workspace. And a workspace is a logical container for resources you need to manage for your machine learning projects. And one of the most important resources here is compute. And remember when I talked about training times and that it would take forever on your laptop? Well, now you're in the cloud, so you can take this massive amount of compute and really, really, really reduce your computation times. But you need compute. The second one is also, pretty obvious. Well, you'll be needing data, right? You need to manage your data, and without data, you can't train your models. And another thing, which I think is absolutely fantastic, is experiments. So in the old days, and the data scientist would be behind his laptop and just trying out things, trying different algorithms, trying different features. Days go by, and at some point the data scientist realizes, 2 days ago I had the best result. Oh man, but what did I use again? Did I use this feature, or did I use that algorithm? Where's my documentation? Oh wait, I didn't write any documentation. Yeah. So now Azure Machine Learning tracks your experiments for you. So you can just easily go back in time and see when you got the best results or when you got completely different results. So that's a really great feature for Azure Machine Learning. Also, Of course, when you have models, it stores the models. You can register and manage them completely in your workspace. And when you're ready to use your models in applications, you can publish them as services. And that can then be accessed over HTTP connections. So that is really a very short overview of Azure Machine Learning. Now, to give you another short overview, let's go to automated machine learning. Because automated machine learning is great. It takes a lot of hard work away from the data scientist. Normally you have to you tweak your features, you tweak your data, everything is ready, and then you're going to run the models. And then you're going to run a model. And then you're going to run the same model, but doing a little parameter a little bit different. And again, you have to wait. You're going to run the model again, doing it a little bit differently. And again, you have to wait. So it's a very boring process, I would almost say. And why not automate this, right? Why not let Azure Machine Learning go through all these algorithms and all these different settings by itself? And then finally, it gives you the best model back. Now, that is automated machine learning. There's nothing to it. And I'll demo this later in the Azure Machine Learning Designer. But before that, let me just quickly tell you about what the Designer is. Because the Designer is a visual tool for creating machine learning pipelines. And a pipeline is basically a multi-step workflow to prepare data, train models, and perform model management tasks. As you can see here on the right side of the screen. On the left side here, you can see that these three main steps are important. You start with a pipeline that ingests data, pre-processes it, and then trains and evaluates the model. And then when you're happy with the results, you create an inference pipeline, which is based on your training pipeline. It will be a little bit different because this inference pipeline only needs to score. So it no longer needs, for instance, to split the data. And if you're happy with that, and the inference pipeline is ready, you can deploy it as a service that then client applications can use. On the right side here, you can see an example of a training pipeline. And note the following. First of all, we need data. So again, we have our diabetes data. Remember, in the classification example, we also had diabetes data, and now we have it again. And I have the data, but before I can use the data, I need to process it a bit. And in this case, I'm going to normalize the data. So what I want it to be, I want all the values to be a little bit on the same level. I'm going to normalize them and making all between 0 and 1. It's a very common pre-processing step for numeric features. After that, I split my data, and one part goes to the train model and the other part goes to the score model. The train model will train my data, and the algorithm that I'm going to use is a two-class logistic regression, which is a binary regression. It's going to predict either a 0 or a 1. After training has been done, my model gets scored, and then in the final module, I can evaluate my results. And I'll show you that later. So with that, let's go to the lab, and I'll show you around. You can do this yourself. Go to aka.ms/nocodeautoml and just follow the instructions there. For now, I'll just create an Azure Machine Learning workspace, show you around in the compute targets. We're going to explore the data a little bit, train a machine learning model, look at automated machine learning, and then we're going to deploy the model as a service and even test it. Okay, so let's go. I've already put the link in a browser, so let me just switch to the browser here. And you can see here at the top of the screen, I already have entered here aka.ms/nocodeML. So let's run this, press enter, and it will open the learning path associated with it. Use automated machine learning in Azure Machine Learning. You can see that the third here is create an Azure Machine Learning workspace, and it will explain to you how to create a workspace, and the steps after it will ask you to go to the machine learning workspace itself and then open up the designer. But let's see first how to create a workspace. I need to go to the portal. I've already opened that in a separate tab here, and I can create a new machine learning workspace by actually multiple ways, but I could click here, I could type it at the top of the screen, I could click here and then add a new one. There are many options here. I can even, if at the flyout panel that that gets here, I can even press create. And it will open up a new window where I can create my machine learning workspace. I have to choose a subscription. I have to choose a resource group, because remember folks, we cannot create resources without a resource group. It needs a name, which is unique within the resource group. I'm going to give it AI fundamentals. Let's see if that's unique. It gives me a green tick, so that's unique. I'm going to provide the region, and since I am from Netherlands, I'm going to say North Europe, and the workspace edition is Enterprise. Again, if you want to use Azure Machine Learning Studio, you will need to choose the Enterprise Workspace Edition. With that, I click Create and Review and Create, and it shows me some of the basics. I check it, everything is correct, and I can press the Create button. I'm not going to do this now because I've already created some workspaces. So let me just go back here, click the Home button, and if I click here on Machine Learning, it will show me my current Machine Learning workspaces. I see that I have 2 workspaces in different subscriptions right here, and let me just click the top one, the AI 900 AML. It brings me to this overview where I can see some of the settings where I chose the Enterprise Workspace Edition. The resource group is AI 900, the location is North Europe, etc. If I scroll down, I see, well, in a big font, Azure Machine Learning Studio, and I can open it up by clicking the Launch Now button. This actually will open up a new tab and starts loading Azure Machine Learning Studio. And here I can use the designer and use the automated machine learning features. It will first bring me to the home page where I can see some of my recent resources, and on the left I have all these settings. So let's go through them and let's start with the assets, and let's start with the bottom. If I want to do some data labeling, I can choose this option. If I want to connect data stores, right here I can have this option, so from external data source. And if I want to connect compute, I can click here. And here I have actually several options for compute. I have compute instances, I have compute clusters, inference clusters, and attached compute. Now, compute instances are really development workstations that data scientists can use to work with data and models. While compute clusters are really scalable clusters of virtual machines for on-demand processing of experimental code. Inference clusters are deployment targets for predictive services that use trained models, right? The ones that you trained. And attached compute is links to existing Azure compute resources, such as virtual machines or Azure Databricks. So that is compute. And we also have an option here, endpoints, but I will show you that actually a little bit more later, since we're going to train a model and then deploy the endpoint. Models, of course, since Azure Machine Learning, like it was in the slides as well, it stores my models and actually also keeps versions of it. I can easily track my pipelines that I created, and I can also track the experiments that I created. And as you can see here, there's currently one experiment, and it's called diabetes. Now, looking at data sets, I have added a data set. This is called diabetes, and if I click on the data set, it will give me some of the general properties, like the size of the data. Now, I'm not interested in the size of the data, I want to see the data. So here I can click Explore, and I can see the data there. It loads the data, gives me the first 50 rows, and gives me the columns. I can see here, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, etc. And on the most right, as you can see, the outcome variable, which is either a 1 or a 0. A person has diabetes or a person does not have diabetes. Now, it is interesting to see here, folks, because when you're thinking about data, you also have to think about how to ingest the data, but also how to prepare the data. Sometimes the data is not ready yet. Maybe there are errors in the data. There is 66 typed out in letters instead of numbers, and it ruins the entire column, or there's a lot of missing data or weird values, and so you have to do a lot of data cleaning, a lot of preparation to make the data ready for the algorithm. Because remember, The model is only as good as the data it gets. Okay, and if I'm happy with this, I can use the data from my model. I could also, create other columns out of this, and this is called feature engineering. So maybe I could combine certain columns into a new column, or I think a great example here would be the date, which is not present in this column. But if I have the date, I could also create a new column with just the week number, or a new column with just the month number, or a new column with the season, right? And that is feature engineering. And then I can create lots of features, and then I have to select which features are important. But I'll show you that during the designer. Okay, and here we have the designer. Let me just click on this here. And if I go towards the designer, it will already give me some examples, which I can already use, build on. And below here, you can see the diabetes prediction. I've already started building this. It's a training pipeline, so let's click on this. I click on it, and it brings me to this new window. On the left, I can see all the modules that I can drag onto the screen. And here I can see the training pipeline that I've already made. Now, when I talked about feature selection, right, because you're going to create a lot of features, and sometimes you just have to select which one are important, there are modules for this. I could do this. I could click the feature selection, and I could drag one of these modules onto the screen and use it. Now, for now, that is not needed. So let's take a look at this training pipeline. It starts with diabetes data. I normalize the data, so I'm converting all the values to be between 0 and 1. So all the columns are a little bit like each other, and it's better for predictions. Next up, of course, right, we're going to split the data into training and validation, and the training set we're going to use a two-class logistic regression tool, which is a logistic regression, a binary classification. So it can classify into two classes, 1 or 0. And when that is done, I'm going to score the model, and I'm going to evaluate the model based on the results, right? I had the predicted values based on how I score the model, and I have, of course, the outcome values that I already had. Now, I can click on this as well. And remember, I can click on each module. So let me just show you that first. I can even click here on this two-class logistic regression, and it gives me some parameters that I can change. I'll get back to this, because if I want to change the parameter here, I have to train the pipeline again, and that will take time. And that is why automated ML, automated machine learning, is so great, because it does it for me, right? I don't have to do this all over and over and over again. Okay, so let's look at evaluate model. So it already ran, so it already did something for me. I made it quite basic. Let's look at some of the outputs. Evaluation results, and I click the third button here on visualize. We'll open a new window, and here I can see some of the metrics and some of the results. Now I'm not gonna go into these top 3, but I think you recognize this confusion matrix, which is the name of this 2x2 table. I can see that 71 cases here got correctly predicted as having diabetes, and I can see 220 cases of correctly not having diabetes. But still, there's plenty of false negatives, because they got predicted as not having diabetes while they actually had not had diabetes. And the same goes here, right? 27. Now, I already talked about the threshold, which we set at 0.5, but I can change this. And with that, also these accuracy and these other metrics change with it as well. Remember when we talked about accuracy and precision? Look what happens if I change the threshold. You can see now that the true positives go down, but the true negatives go up. And here also, there's also a shift here, right? 8 and 102. You can see that the accuracy changes as well. Now I can move it to the left, and you can see the opposite happening, right? The true negatives go down, but the true positives go up. And it's really dependent on the use case. And this is some homework I'm giving you. Think about, for instance, pregnancy tests. What is important there? I'm not going to spoil the answer for you folks. You'll have to find it out yourself. So that is really an easy way with a designer to create a machine learning model without using any code. I can just create this, run it, and I'm done. And when I'm happy with this, I can create an inference pipeline. For real-time inference pipeline, I can click this button, but it's grayed out. And it's actually quite simple why it's grayed out, because I've already created this. And because I created this, there is a button here that's now become available, real-time inference pipeline. I click on it, and now it opens this inference pipeline. It's a little bit different, because remember folks, I don't have to split the data, I just need to score the data. And I'm going to score the data using some web service input, and then I'm going to provide the outcome to a web service output. And I can publish this model, I already did, and now an endpoint becomes available. And I stalled it a bit, but here we go. Let's go to this endpoints part right here. Diabetes prediction. I'm going to click on it. I'm going to get some properties of this. I see the attributes, I see the REST endpoint, and I see how I can consume it using this tab. It also gives me some code, it gives me some keys, it gives me the REST endpoint. Really easy to use this. And even better, I can also just test it. If I click on test, I can see some of the values I can give it. I can change it if I want. So age 50, I can make it 77. And then I can press test right here, and it will give me an outcome. Also remember that the probability was always between 1 and 0, and that is also the case here. Scored probability is 0.7, which results in a scored label of 1. So it is predicted that this person would have diabetes. Now let's take a look at the automated machine learning, because I promised you that, so let's go there right now. I'm going to click here, and here it is. I'm going to click a new, I can create a new automated machine learning run by clicking the plus button. And here it is. It needs a data set, obviously. And I only have one, it's diabetes. I'm going to select it and I'm going to press next. Next up, it needs some other things. It needs an experiment name. And well, I'm actually going to choose an existing experiment because it's all for diabetes. And it needs a target column because it needs to know, what am I going to predict? And here it is. The bottom one is outcome. When I click it, it needs a compute cluster. I've already created that, so that's great. I don't have to do it. Click cluster 1, and there it is. I click next. And now it needs the type, right? It already found that it is a classification algorithm that is needed. So there's a green tick here. And I have some additional settings that I can choose from. So let's click on that. Additional configuration settings. Do I want my model to be explained? That's not needed for now. And do I need to block some algorithms? Because maybe I already know some algorithms that are going to work and some algorithms that are absolutely not going to work. So I'm just going to block them. And it also makes the training a little bit faster. I'm going to leave that for now. And I also have this featurization settings. And here I can see that, do I want to auto-detect the type? And maybe I can set it manual as well, that it's numeric, that it's text, or maybe even a date time. And if there's missing data, how do I want the data to be imputed? Do I just want to take the mean of the data, or do I want some other kind of option right here? But I'm going to leave everything at automated right now. And with that, I can press finish. And if I press finish, it will just start iterating through all these algorithms and just find the best model for me. Well, this can take several hours, so I'm not going to do this. I already had it run for 7 minutes, which is not a lot of time, but it finds some kind of model. And I can see it right here. On run 18, you can see here at the right, it ran for 7 minutes. So let's click on this one. And here I am. Properties, I canceled it after 7 minutes because I was done with it. I was like, okay, let me show me the results. And here on the right, it shows me the best model summary. It found out that the random forest gave an accuracy of 77%, and that was the best model. And I can view all other metrics, give me a complicated list of different metrics. Well, not a complicated list, but a list of metrics. And I can just dive in there here. I can even see child runs, all the different runs that it did, some different output, etc. So without creating the pipeline, I just gave it the data, remember? I did some minor settings, and now I have here an algorithm that gives me a 77% accuracy without doing a lot of work. So hopefully that was a useful demo of the automated machine learning and the Azure Machine Learning Designer. Just to wrap up, in this module, we talked about the introduction of machine learning, and we talked about regression with a continuous outcome and numeric value, for instance, age. We talked about classification, really trying to classify something, having diabetes or not having diabetes, a 1 or a 0, a true or a false. And finally, we talked about clustering, right? Trying to find clusters in the data. After that, we talked about Azure Machine Learning. I showed you around what is machine learning and that you needed a subscription for it, and that it is a logical container to keep all your resources in. I showed you around in the designer, in Azure Machine Learning Studio and the designer, where we could drag and drop modules and easily create a training pipeline. And I showed you the automated machine learning. Without too much settings, I can just give it the data and let it run for itself, and then after some time, it will give me back the best performing algorithm. And with that, let's take a 10-minute break, and I see everyone back here in 10 minutes to begin Module 3. Welcome back from the break, folks. Hopefully you got yourself a refreshment and stretch your legs a bit. So far, we've discussed artificial intelligence, we've discussed machine learning, and now it's time for these three broad topics, right? Computer vision, natural language processing, and conversational AI. First up is computer vision. So let's get started, module 3. And in this module about computer vision, we're going to look at, first of all, what is computer vision? And then we're going to look at some examples, some applications of computer vision. And in the second part, we're really going to dive into computer vision in Azure. We're going to look at cognitive services, we're going to do some image analysis, right? Getting a description from an image. We're going to train our own model using the custom vision service. So we'll be classifying some fruit there, analyzing faces, reading text, and analyzing forms with the form recognizer service. But before we dive into that, let's really think about what is computer vision. What is the concept behind computer vision? And well, where does the thinking start is how you can get information from a picture, right? Because computers see the world through pictures, or photographs, live camera feeds, recorded videos. But how do you get the information from it? Where does it start? Well, if we're looking at a picture like this, it's a nice picture. You can see some cyclists on the bottom right, and there's a bus on the top left, and there's a gray car as well. Well, this image is actually built out of pixels. And it is actually an array of numeric values indicating the color intensity of each pixel in the image. Now I'm going to plot this because the color intensity ranges from 0 to 255. So here it is. And in the case, this is actually not completely true, because in the case of a colored picture, it is actually 3 values that range from 0 to 255, which is the color coding, the RGB value. Now, if I am looking for a red pixel, my algorithm can scan through the image, and will probably find that around the bus there are a lot of red pixels. And in case of when it's finding these colors, it only needs to go through all of the pixel and then find approximate the right color codings. However, looking at this picture, and it's in computer vision algorithms, they don't only detect just a pixel, right? They detect patterns. So for instance, how would a computer vision algorithm detect a line? Well, in this case, it wouldn't scan just one pixel, but it will scan a small square. And by looking at this picture, if we're looking at the lines on the road here, you can already see the rest of the street is darker gray. So there's a large color difference when you're indicating a line. Well, and this is exactly how an algorithm finds such patterns: a line, a corner, a circle. So that is really how an algorithm of computer vision extracts information from a picture. And with that, let's look at some examples. Yeah, some applications of computer vision. The first one is image classification. In this case, the model uses the numeric pixel features to predict a class label for the image. And you see here a taxi, so it recognizes it. It's probably because of the shape and the thing that has put on top and the color. So that is image classification. There's also something called object detection, where we train a model to classify individual objects in the image and to indicate their location within the image as a bounding box. And here you can see it, right? There's the bus, it has a bounding box around it, and there's a car, there's also a box around it, and you can see that also these two cyclists are bounded. So you know where they are in the object, where they are in the picture, and what they are in the picture. Now, there is something more advanced, and that is called semantic segmentation. And semantic segmentation models are an advanced kind of model that classify individual pixels in the image based on the object they belong to. So in this case, you see that the car, actually all the pixels of the car got classified correctly, and they were given a blue filter here to really distinguish it. Another example here is image analysis. You can see that there's an image, and you will get a description back. The algorithm will generate captions and tags based on the content. And we'll see a short demo of that later. We have face detection and recognition. It's used to, for instance, identify human faces, but it can also be used to identify facial features such as gender, emotion, age, and it can also be trained on a specific group of people. So when I go to the office in Amsterdam, there is a camera and a video screen. It's just for fun, not for security. And when I walk towards the camera, the screen will say, "Hello, Tigo," and it will sadly estimate my age a little bit too high. But no, again, it's a great tool, and so you can do a lot of different things with it. Last one is optical character recognition, and that is extracting text from the image. As you can see here on the example, it says the Toronto Dominion Bank, and indeed it correctly extracts the text from the image. With that, let's move to a short demo here. And for this demo, I'm going to go towards a browser. I've already opened up the link here, aidemos.microsoft.com/computer vision. So I'm going to run that right away. And here we see it. So here you can, look at some of the applications of computer vision. And we're going to look at analyze and describe images. And I can pick an image here on the right side of the screen. So let's pick one here. Let's go with I think it's a taxi somewhere. And here you can see what happens. The algorithm recognizes the picture. It provides you with tags. So in this case, you can see that it's 100% certain that it's a building, there's a car, there's a road, and as it has more tags, the confidence go down. So it's only 16% confident that that is a curb. There is a curb in this picture. It gives you a description, so it says a car parked on a city street. Yeah, could be the case. It could also be in case if I look at this picture that maybe it's waiting for a traffic light. Could also be. And it's telling me that there is no racy content and no adult content in this picture, and it's very certain that there is not. Let's try another image here. Picking out another image here. Let's try this one. Beautiful picture with some water. I see some buildings, I see some trees. And again, the tags here as well, that it recognizes some trees. It sees that it's outdoor. It's 68% confident that there is a lake. Okay, I'm not completely sure about this. And there's the right is only 18% confidence. The description here, what it gives you is a bridge over water with a city in the background. Okay, and there is no racy content and no adult content. And this is really the AI algorithm giving you a description, giving you tags back based on a picture. Okay, let's look at something else. Let's go to the next step. Read text in imagery. I already showed you a small example of this optical character recognition. And let's see how it works in real life. So I'm going to click on a picture here, 42 Street. And the transcript, it extracts the text from the picture and it says 42 Street 42. And the second 42 is also correct because I can see here on the right hand side of the screen it says 42. Okay, let's try another image here. Let's see if we can find if it makes some mistakes here. Again, no, it extracts the text from the image and it says no pet crossing, use crosswalk. And the transcript, yeah, it seems to be correct. So really, OCR, optical character recognition, extracting text from an image. Now, it doesn't only have to be like typed text, it can also be written text. So let's see here. We have a free hugs. You see a picture here. And again, you can see that the transcript below is free and hugs. So this handwritten OCR also works very, very well. Let's try another image here. I see here, this looks interesting. Steel cut oats with apricots, cranberries, and spices, served with yogurt or milk. And the transcript seems to be almost correct because I do notice something that there is a 1. There's a transcript with a 1 and a dot, and maybe that has to do with some of the vertical lines in the picture that gets wrongly classified as a 1. So again, folks, it works very, very well, but it's not always perfect. Let's look at something else. Let's look at recognizing celebrities and landmarks. Well, since I am maybe biased towards a certain picture, I think you can already guess which picture I'm going to choose to see if the algorithm correctly recognizes a celebrity. And here it is. The algorithm runs, it sees the picture, and it correctly identifies Satya Nadella, 100% confidence, as being the celebrity in the picture. It's really a great way to just play around with these kinds of algorithms. And you can find them at aidemos.microsoft.com/computer vision. Okay, and with that, let's go back. And now let's take a look at computer vision in Azure, the second part of this module. I will start with cognitive services. Because Azure provides you a set of cognitive services that encapsulate common AI workloads, such as computer vision. And you could build your own computer vision model using machine learning, but to be honest, it's a complex area, and it will take you a long time. And I'm not even talking about training time, but getting up to speed with current technologies. It's a lot of work. And using off-the-shelf services can help you develop a solution more quickly and with a lot less specialist expertise that you would need. Now, to use cognitive services, you must provision a resource in your Azure subscription. So you need an Azure subscription, and you need to provision a resource. It can be a standalone service-specific resource, for instance, computer vision, or you can use the general cognitive services resource that encapsulates all the multiple services. Using a standalone service-specific resource enables you to manage your costs and access independently of the other services, while a general cognitive services resource enables you to combine all of your AI services in a single Azure resource. And that was really for centralized management. And regardless of the type of resource you use, at the end, the client applications will consume the services it provides by connecting to a REST endpoint. And of course, you need a resource-specific key for authentication. When we're looking at image analysis, the computer vision cognitive service provides a pre-trained computer vision model that you can use to analyze images. And the model can detect and locate over 10,000 classes of common objects, like you see in the picture here, a person, but an apple, a couch, a dog, a mountain, or jeans, as you can also see in the picture. And it can generate automatic captions for the image and a set of relevant tags that relate to its contents. And these tags, they're very useful, because if you need to index images and search for them using relevant keywords, you can use those tags. And we'll look at some fruit later, and then you will see the use of tagging. But we'll get there during the demo. The algorithm can also detect and analyze human faces, including gender identification, and can estimate ages. It can moderate content by identifying images that contain adult, racy, or gore content. And last but not least, there is OCR. So it can detect and extract text in an image. Now, this is a pre-trained computer vision model, but you can also enhance a pre-trained model. So you can train your own model, and you do this by using the custom vision service. And you could then use it for image classification or object detection. And the service provides a web-based portal. It's really easy to use. You can upload your own images. You can label the image then, or the objects inside them, and then train and deploy a model. And then, of course, you can again consume the model using the endpoint and key for the resource. But I'll show you this in a demo shortly. We also have analyzing faces using the face service. And while the computer vision service provides some basic face detection, the face service offers additional capabilities. And that includes the analysis of facial attributes and the ability to compare faces for similarity, or even train a facial recognition model to verify the identities of individuals. Really interesting. Reading text we have. We already discussed it a little bit, but of course you can use it to extract printed or handwritten text, and there's options to quickly extract this. You can. It provides multiple APIs, so software developers can use this. An API is an application programming interface. And a software developer can use to extract these and then implement it in maybe an app. And last but not least is analyzing forms. So the form recognizer service offers more than just detecting and extracting text. It enables you to use models that understand the form fields. For example, identifying specific types of data such as addresses, phone numbers, dates, times, quantities, and then understanding the relationship between the field labels and values. And you can use the form recognizer to train your own model based on, for instance, some receipts you give it. So I could use it to digitalize all my collected receipts from a certain restaurant or a certain shop, and then as the model is trained, I can then extract all the information from all the receipts into, for instance, an Excel table. Okay, and with that, let me just show you around with the custom vision service in a demo. So I'm taking the aka.ms/learn image classification. Let me switch to the browser here and then put it right there. And it will open this classify images with the custom vision service. I can click on the create image classification solution. And it will open the exercise. Here I can see that I will need a Azure subscription and I will need a Azure Machine Learning Workspace, which we created earlier. Now, within the Machine Learning Workspace, if you have already created this, we are going to create a compute instance and we're going to download the exercise files. Now, for this, to easily and quickly navigate to that, we can go to this link, ml.azure.com. Let me click on that. And here it will open my machine learning workspace. It automatically redirects me to the AI fundamentals workspace. Sometimes it does ask you which workspace you want to navigate to in case you have more. But for me, I only have this one. Now, next, the exercise asks me to create a compute. And on the bottom left, we see that there is compute here. I can click on that and I can click the create button right here. I can give it a name. So let's call it compute AI 900. Let's see if that is valid. Seems to be. DS2. Let's pick another size here. So the standard here is DS3V2. It asks me to create a DS2V2. Okay, let's go back. So we have that, and let's create the compute. Now, this will take a while. It needs to spin up a virtual machine, basically, that does all the compute for us. Now, if I go back to the exercise, so I'll Alt-Tab back into it, it also asks me to download the exercise files. In the studio, where we are, we can create a new file, and then we'll paste the code in there. So we will be using notebooks for this. So I'll copy this code. I go back here, and on the left here, and I can click this to show you the names, and the little hamburger menu on the top left, we see that there is a tab called Notebooks. I click on it, and here I could create a new notebook. Let's see if I already have some notebooks here available, which I have not. Spoiler alert. I'm going to create here a new file, and we're going to call this the AI 900 import. And the file type is a notebook. Sure, I'll override it if it's already existing. And this is just a notebook, so I can run this copied line of code and import the actual exercises here. Now, what you'll notice right away is I haven't attached it to any form of compute yet, and it will tell me this. Your document is currently not connected to compute, but you will see that it is actually already finding the compute, but the compute itself is still creating. Okay, so let's close this message. We'll have to wait for this in order that we can run the code. So I'm going to close the message here, And here, remember that I copied a line of code. I'm going to paste the code in here. And here it is. So this line of code will basically clone a GitHub location to my folders here. So while it's creating, let me just quickly navigate to this right here so you can see what it is. And while this is loading, you can see here that this GitHub contains all the exercises from object detection, image classification to language understanding. So we're cloning these files into our Azure Machine Learning Studio. Okay, so let's go back. As you can see, it is still creating. So meanwhile, let's check what the exercise wants us to do. It wants us to press the run button as soon as the compute, of course, is up and running, and then we'll complete the exercise as is in the GitHub. And we'll do the image classification exercise here. Okay. And now you can see that the compute AI 900, it's up and running. So now I can actually run my code here. So I can play the run cell, click on the run cell, and I will see some output here. Cloning into AI fundamentals, it's receiving objects, etc. So it pulls the entire information from the GitHub and puts it in under my user files right here. Now, it's checking out the files, and it's done. Now, as you can see, I don't see anything here yet, but let me just press the refresh button right here. And here we are. There is now a new folder called AI Fundamentals, where we can see all the exercises right here. So here we are. We've opened the notebook, image classification, and as we can scroll down, we will see the exercise. First of all, it will ask me to create a custom vision resource. So let's do this right away. I'll go back to the portal, and as you can see here, it will ask me to create a custom vision with the training pricing tier F0. Okay, so let's do that right away. I'm in the portal. I'll click resource groups right here. And here I have my AI fundamentals resource group. And let me create something in here. So I'll press the add button. And I'll type in custom vision. And here we are. I'll press the create button. And of course, we'll need to give it some basic information. So we'll have both the training and prediction. We have our internal subscription. We have our resource group AI fundamentals. And we'll call it a name, and that will be the AI 900 custom vision. Is it already taken? It is already taken. So let's call it the AI fundamentals custom vision. That's still free. Then I'll need to specify my training resources. I want it obviously in the West Europe, since I'm from the Netherlands. Pricing tier, I'll use the standard tier. You can use the free tier, but I'll probably have already some resources running. So then the free tier will not work. So I'll choose the standard here. I'm also going to select this one, West Europe. Pricing tier will be the standard tier. And I'll go to review and create. I'll create this. And while this is creating, let's check what our next exercise is. So I'll go back to the machine learning service. I'll scroll down. And next up in the exercise, it wants me to create a custom vision project. And it will, I need to download and extract training images from aka.ms/fruit images. So let's do this right away. I'll go here. Now, if I open this in a folder, I can see that there is now a zip file called training-images. So let me unzip this, extract all. Okay, great, extract. Will give me a new folder here, and within that are 3 folders: apple, banana, and orange. Apple will contain pictures of apples. Yeah, you see some red apples here, some green apples, etc. Now, if I go back here to banana, you might be surprised that there are banana pictures in this. Okay, and the same, of course, goes for orange. It's not an orange folder, but it contains some oranges. So we have that. Now let's go back here. And it wants me to open in another browser tab the custom vision portal. So I can right click on this and then open in a new tab. Don't click on it, folks, otherwise it will open that link and it will shut down this studio. So open in a new tab. And here we are. Visual intelligence made easy. I'll sign in. And here we are. And what do we need to do? Well, we need to create a new project called Grocery Checkout, which I'll copy right away here. And it needs to be a classification project type and a multi-class classification type. And then we're going to add some the pictures that we downloaded before, and we'll take the domain food, because the algorithm that we're going to use is already a little bit familiar with types of food, so that will help us in our predictions. Okay, so let's go to Custom Vision Projects. I'll create a new project here. The project name I just copied, so I just paste it here in fruits. And let's see, it's a classification, it is a multi-class, and the domain is food. So click on that, and that will create the project. Now this will create a new sort of workspace where I can do various things in. I can add the images, I can see if they are tagged, so if they have almost like a clothing tag attached to them, and then we can start training this model. So first of all, what we can see here is in the center of the screen, there is add images. We'll need these, the training images. I'll go towards apple, and here I'll select all the apples in the image, Control A, I'll open them, and here we have them. Now, at the bottom of the screen here, you see add some tags to this batch of images. And in this case, my tag will be apple. So every picture here gets tagged with apple. I'll upload the 15 files. And we're done. And now we can see them right here in the center of the screen. As soon as I click on one, you can see a larger image of the apple itself and the tag apple. Okay. So let's add the other two as well. I'll press add images again. I'll go back to training images. We'll go to banana. And I'll select all the bananas in here. Now I will add a banana tag to them. I'll upload them as well. And as you can see, they will show up right here as well, together with the apples, all nicely together. Now, last but not least, oranges, don't worry, we'll add you as well. So I'll go back to training images, click on orange, and I will select all oranges right here and give them, of course, the appropriate tag, orange. Orange. Live typing, always difficult. Okay, they're uploading, and also these 15 images uploaded successfully. Okay, and as you can see now, as I scroll down here, we see oranges, we see bananas in various positions, right? Some here you can see it's lying like this or the other way around, and we see apples also photographed from different orientations, and even also apples with different colors. Okay. Now at the left side of the screen here, I can see that I have currently showing all the tagged images. If I click on untagged, it will show me all the untagged images, which I do not have any. So close that one as well. So luckily all my images are tagged, and I am completely happy with this. I could filter down here. If I just select apple, then I will only be shown the images of apples. Okay, So now we are ready. We have our images of apples, bananas, and oranges. And now, we can train our model. But let me just show you the exercise. Where are we right now? So we've added the images. We've specified a tag. We've done this as well. And now we are going to select the quick training option right here. And then we'll do a quick test. So I'll go back here. I'll do a train model, quick training. I'll press the train button, and now it will start training a algorithm to detect these 3 kinds of fruit. Meanwhile, it will not take a long time, but meanwhile I can show you that we're going to test this through this link, https://aka.ms/apple_image. Now, just to show you this shortly, let me open this link up and paste it in here, and this is the image that we're going to use to test the algorithm. It is a picture of an apple. As you can see now, the training has been completed. It gives a high precision recall and AP, so it's performing quite well. Now let's give it a quick test, as I explained earlier, clicking the quick test button, and now it will have, I will have to put in the URL. So I'll put in aka.ms/apple_image. And here we have again the apple, and now it will give me a prediction based on the algorithm we just trained. Okay, so is absolutely sure, well, 99.9% sure that the picture I have just uploaded is actually an apple. So it's performing quite well. Okay, I'm happy with this. Hopefully you are as well. So let's close this now and publish this, right? And make it available. Performance, and then on the left side here I have the publish button. So I'll click that. I have a model name, which is groceries, and then I'll choose a source here, and then I'll press publish. Okay, so the model is now published, which is great, and I'll need some information now. So let me just go up to the top right of the screen. There's this little gear icon. I can press it, it will show me some information. Let me copy the project ID here, which is as well requested in the exercise. So if I now go back to the exercise and I'll scroll down a little bit, it says here after publishing, click the settings icon and copy the project ID. Okay, in the code below. So if I scroll down in the code below, then it selects this box. So let me delete this and then paste in the project ID. Now, to avoid confusion here, we did this, and then it will tell you something, because I need the information which is called a key and an endpoint. And if I go back here, I can see a key and an endpoint, but this is not the correct one, because this is from our training, and we need to go to our prediction. So I go to the top left here, click the I button here, and now I can, on the right side, I can click the gear button right here, and then I have here the top one is the one that contains the correct key. Copying this one. And the correct endpoint. Just as easy, you know. Okay. Pasting it right in here. Model name is indeed groceries. So now if I press the run button, it will say ready to predict using model groceries in project, and this is the ID of the project. Okay. So we're gonna install some things here. Because you'll need some custom Python packages for this, but you don't really need to understand this now. You'll just need to run this code, and as you can see, it's actually already installed, so I didn't even have to run it. Okay, and here what it will do, this is a box of code, and let me just quickly simply walk you through it. It will take some images, and basically in a loop, it will predict those images. And then it will show me a little plot. Okay. So I'm just going to press the run button right here. I'm going to scroll down. And here it will say classifying images. And now it will loop through the images and classify each image. And after that is done, it will show me the results. So as you can see, it's still running. There it is. It's done. And now I can see here. I can even scroll down a bit on the right side, but I've given it some apples, some oranges, and some bananas, and they are all classified correctly. So you've seen now how easy it is to create an image classification solution. And there were additional exercises that you can do yourself as well. So if you can go to aka.ms/explore computer vision, that will bring you to 6 modules about the computer vision in Azure. So let's go there now. I'll open it up. I have a tab here open. Let me just press enter here. Okay, and it loads the learning path. Explore computer vision in Microsoft Azure. And remember that we talked about, image analysis, analyzing faces, reading text, and analyzing forms. Well, each of these has its own module here. So analyzing images, classifying images, which I just demoed you, detecting objects, detecting faces, reading text, and analyzing receipts with the form recognizer service. So go through these at your own pace and learn more of the services we have to offer. And that brings us to the end of this module. And in this module, we talked about what is computer vision, how do you get information from a picture or from a video? How does an algorithm do that? We'll talk some of the basics around this, right? We looked at some of the applications of computer vision, some examples here, and then we went into computer vision in Azure, where we looked at image analysis, reading text, analyzing faces, talked about the form analyzer, and I showed you around in the portal and where we created a custom vision service. Remember, we classified bananas, apples, and oranges and trained and published our model. Let's take another 10-minute break, and I'll see everyone back to begin in 10 minutes to begin Module 4. Welcome back from the break, folks. So now we will be diving into our last modules, Module 4 and Module 5. Module 5 will be around conversational AI, right, bots. And after that, we'll do a recap of the entire course, what we learned today, what we discussed today. And then, you're free to go to do all the exercises that I haven't done yet. I haven't demoed yet. There's still a lot there in the Visual Studio Codespace. So with that, let's get started with Module 4. And in this module, we're going to look at natural language processing, also called NLP. It makes it a little bit easier. And we'll start with an introduction, and then we'll go into, natural language processing services in Azure. And we'll take a look at those. We'll take a look at text analytics, speech recognition and synthesis, translation, and language understanding. But first, let's look at these words, right? Natural language processing. What is it? Because we have language processing, right? We have programming languages like Python or C# or Ruby, you name it. And you can type a sentence and you can execute the code, and the computer will understand it. But the thing is, the difference here between natural language processing and normal language processing is that a programming language has to be precise. If I make a typo, it will not work. All the developers here can absolutely agree with me, hopefully. And natural language is something else, right? Because it has a large vocabulary. There are words with different meanings. There are accents, dialects, wordplay, and many other things. So that's really the difference here. And that's what we're talking about if we're talking about natural language processing, really how we do language. Now, what are some of the areas in AI? Well, we have text analysis and entity recognition, where you need to analyze a text document and you need to find out the important points of the important persons mentioned in that in the text document. So even dates or places could also be, right? And then you can do text analysis, entity recognition to collect those. And an example here would be a company that would do this to analyze industry magazines to see, where are they mentioned or when are their products or executives mentioned. The second one is sentiment analysis, which actually fits this example perfectly because it is a form of text analysis that calculates a score of indicating how positive or negative a text extract is. And in the case of a company that has that searches through these industry magazines, so every time it finds that it's being tagged or some of the products are there in that magazine, it can also check the sentiment of that magazine. So they can investigate how are they being perceived, right, in a positive or a negative daylight. Another example here is a company, has products and it gets reviewed, and then they go through the reviews with the sentiment analysis to see what the average is. And a very common example here is Twitter. And you can go to Twitter and then see the sentiment there of some subjects. Speech recognition and synthesis. So it is increasingly common to encounter AI systems that can recognize spoken language. Right, it's becoming really, really normal. An in-car system, right? You have this hands-free communication because it can read incoming text messages aloud to you, and then you can dictate a response verbally. Or the voice assistant is another great example here. Machine translation. Often there are language barriers if you have international or cross-cultural teams. And eliminating those is a key to success. And being able to translate it into different languages is very important, right? There is some spoken language, and then you automatically get spoken language in a different language back, or an email, or it was in an inbox you can automatically translate messages, or a transcript. So somebody speaks in, for instance, Japanese, and you just see a transcript below the meeting in English. Machine translation. And then we have semantic language modeling. So because language can be complex and nuanced, and multiple phrases might mean the same thing. So where can I get gas near here? If you're looking for, you're almost out of gas and you're driving your car. And it can be the same as what's the location of the closest gas station, or give me directions to a gas station, right? All mean the same thing. And you need a semantic understanding of the language that is being used to see what the driver in this case would need. Right, so it really depends on the situation where we're in. Every job has its own language almost, right? So that is semantic language modeling. And if we're looking at the services that we have in Azure, of course, we have our cognitive services, and within the cognitive services, we have text analytics, speech, translator, and language understanding. Now, you can build your own custom NLP models. Absolutely. You can use machine learning, some toolkits. You can use Python, probably other languages as well, but I would really recommend Python. But it's a very complex area, and it will take you a lot of time. You will need the expertise. So why not use something off the shelf that helps you develop your solution way more quickly, and you don't need all the expertise behind it. Right, so in cognitive services related to text analytics, we have the language detection, key phrase extraction, entity detection, and sentiment analysis. And I'll have a short demo on this shortly. We have for speech, we have text to speech, and speech to text, speech translation. And for translator text, we have text translation. And for language understanding, we have the custom language modeling. And we'll get to all those in a minute. So let's start with a little demo here. So you can do this demo yourself at home at aidemos.microsoft.com/textanalytics. So let me just copy this and put it in a browser. So I'm in this slideshow here and entering, I already have it here, so I can see it here, aidemos.microsoft.com/text-analytics. Pressing enter here, and it will load this text analytics demo environment, and you can enter anything you would like. Enter your message here. There's already an example here, but let's do something else. Let's type Microsoft has the AI fundamentals course, which is a great way to learn the foundation of AI. How about that? So next step, let's see some sentiment and key phrases. The algorithm finds it, and you see here on the right, it's 89% positive, and you see some key phrase here. Microsoft AI fundamental scores, foundation of AI, great ways. So they're highlighted in blue. Next step, we're linking some entities. So we're gonna link them to Wikipedia pages. Here, if I click then on AI, you can see it brings me to the page of artificial intelligence. So that works. But I can also just list it below by Bing entity search, and then it provides me relevant information here at the bottom. Nice, right? Okay, so that's a super easy demo, but it really shows you the power behind it, right? Let's try some other sentences. Let's do natural language processing is the area of AI that deals with making sense of written and spoken language. How about this? Okay. You can see now at the right, 91% positive. Interesting. Natural language processing is highlighted. Area of AI is highlighted. Sense of written and spoken language, you see that highlighted as well. So let's do some entity linking, and let's see if it does natural language processing. Let's see if it does it correctly. Does it bring me to the right page? And yes, it does. So it works. Great. And we're going back. Okay, and then a Bing entity search and provides me this relevant information. Okay. Start over. Now let's take this the common sentence here, right? Saturn is the sixth planet, etc. Please clicking next step. And you can see here Saturn, solar system, Jupiter, gas giant, etc. So there's a lot of entities here. Let's see if it finds them all. Yeah, you can see a lot of here. Solar system, Jupiter, Sun, Earth. Next step, Bing entity search. And you can see all this right here. And this just uses this natural language processing, uses sentiment analysis, key phrase extraction, entity linking, and in a very simple demo, right? So let's go back to the slides. So let's continue with the second part of this module, that is really using natural language processing services. Let's take a look at each one of them. So the first one is text analytics. And as the name suggests, it is used to analyze text documents. For example, you use the text analysis services to recognize the text, "I had a wonderful vacation in France." And then the service itself, they can determine the language that the text is written in. So it will probably say predominant language, English. Next up, the service, and we had 4, remember? It can evaluate the sentiment of the text. So let's see what a sentiment analysis does. 88% positive, because wonderful, huh? Seen as a positive thing. And the third one is it can detect key phrases. So what would be the key phrase here? Wonderful vacation. And the last thing, this is entity recognition. And well, my guess is that France would be an entity here. And indeed, it correctly identifies France as an entity. Okay, so really a simple example of text analytics. Now, when we're looking at speech recognition and synthesis, it's a bit different. The speech service provides a speech-to-text API that you can use to implement text recognition functionality. And this service supports text transcription in more than 60 languages. And conversely, the text-to-speech API can synthesize audible speech from text, which with the option to specify regionally appropriate voices for human-like pronunciation. That's the other option. So that's really speech recognition and synthesis. Now, when we're talking about translation, the translator text service enables you to translate text between more than 60 languages. So bonjour to hello. And you can also translate audible speech by using the speech service. And then it has the ability to produce translated output in text or audio format. So you say hello and you get hola in return. And then we're talking about language understanding. And this is also, by the way, known as LUIS. It enables you to train a language model that can interpret natural language commands. So an example here would be switch the light on. And in language understanding, there are 3 things that you have to remember: utterances, entities, and intents. Utterances are phrases that a user might say, switch the light on, turn the fan off, turn the fan on, turn the heater off, etc. That is an utterance. And an entity is a specific item that is referenced in an utterance. And let's talk about, like, we're doing a home automation here. We're trying to make everything automatic, and we just can say switch the light on, and then the light switches on. An entity in this example would be a light, or a fan, or music. Voice assistant, turn the music on. Could also be something. So then light or fan are entities. So utterances and entities, and the last one is the intent. Because what do we want to do with it? What is our intention? And the intent identifies the desired action for an utterance. So let me just show you a couple of demos here. So I'm still on this side, and let's go to aidemos.microsoft.com/Lewis/demo. And here we are. And now it states, there you see a house, make a statement about lighting and Lewis, and I can either type something or I can say something. So you can see that there are some lights are on and some lights are off. And let's see, because I haven't tested this yet, call Batman. Let's see what it does. And there you go. See? Hey, call Batman. So just a very short and short demo of how this works. And you can also type something here, or just or click one of the examples here, and then you can see that indeed it processes the language and then performs the actions. Just a very short demo. Okay. With that, let's go to another lab at aka.ms/learnlewis. Okay, and here we are in the exercise, create a language understanding application. And if I now go to notebooks, remember we've already cloned the GitHub repository. Now I just need to select the appropriate exercise, which is language understanding. And here we are. Okay, so in this exercise, we are going to create a language understanding. So let's do this first. Language understanding. Let's go towards the portal. I'll select the AI Fundamentals resource group. I'll click the Add button, and then I'll do language. And luckily it already auto-completes it for me, so that saves me a little bit of time. And let's create it. My subscription and resource group are already there. And now I just need to give it a name. So AI Fundamentals Language. That is still free, so that's good. Now I need to select a location for both the authoring and the prediction. Well, of course, since I am from the Netherlands, we're going to take West Europe. And here also West Europe. Okay, awesome. Next, I'm going to review and create. Looks all good. So let's create this. So while this is validating, we'll only take a couple of seconds to deploy. Let's go back to the exercise. Make sure you choose the free tier. So if you were observant, you saw that I chose the standard tier because I cannot have too many free tiers running at the same time. So for me, it was the standard tier, but you can just go for the free tier. Okay, now then we need to create a language understanding application. And we're going to do this in a new browser tab. So don't click on this lewis.ai, but do a right click and then open in a new tab. And then we're going to create something called home automation, which I'll copy right away. And we're going to give it the language understanding prediction resource. So right click here, open new tab. Okay, I'll log in. It will ask for my credentials, and it already knew these. So here we are. Okay, I'll need to choose a subscription, which is my Azure internal subscription. Choose an authoring resource. Here we go. Okay, and then I'll create a new app for conversation. What was the name again that it wanted me to give? Oh, wait, yeah. Home automation, culture English. So go back here. Home automation, culture English. I give it a description here. Yeah, just a description. And here I choose the AI Fundamentals language. I'll press done. And here we are. Now, of course, there is a little bit of a walkthrough here, but let's close this for now. You can do this when you're exploring this in your own time. And now we have something here. You see on the left side, intents, entities, pre-built domains. Now go here, create an entity, create, and I call it device. It's a list. Press create, and we have created our first entity called device. Under normalized values, I'll type in light, and the synonym here will be lamp. I'll add another one, AC. Oh, this should be lamp. And this should be fan. So I've added these two values now and their synonyms. Okay, so go towards intents here. I'm going to click the Create button, switch on. And here we have it. Switch on. You can see it at the top right here. And now we need to add some utterances. And that's it. Turn the light on. And it will automatically underline the light here since that is a device. So next up, I'm adding a second utterance to the same one, which is turn the fan on. And press enter. Turn the fan on. Okay. Next up, we're going to create a new intent, which we call switch off. And then in this intent, we're going to add two utterances, turn the light off and turn the fan off. I'll go to intents, and then I'm going to type switch off, add that as well, and add some utterances. So I've already had this copied, so I'll press enter here and I'll paste it again, but change this one to fan. And again, it recognizes automatically the devices in the sentence there. Okay, so I've added the intents, I've added the utterances. So we're done with the create intents part, and now we're going to train and test our model. So we're going to train the model, and then we're going to test the model, and we're going to copy in some phrases here. So let me just copy one themselves. I'm only going to show you one, but if you're doing the exercise yourself, you can try out the others as well. So let's go back here to the Lewis, and then on the top right, you'll see a button with a red circle around it. Press train. Now, in this case, it will start training the app and starts recognizing the utterances, and that will only take a couple of seconds. Here we are. And now I can actually go to, you see that the green circle, it's now green. Before it was red, so it's now a trained model, and now I can test it right here. I can test an utterance by typing switch the light on. I press enter, and it indeed will find the switch on. So that's good. It works. Great. So let's close this again. And now we will publish the model, and we will configure the endpoints a little bit in the same way that we've done before with the image classification. So we'll publish it. We'll go for a production slot. So it's now published, and now I can go to the Management tab and select the application ID right here. Press the copy button, and I'll need it in this exercise right here. Yeah, let's see here, it will ask me for my Lewis language understanding application ID, so I can just paste this in there. Now, of course, I also need the primary key and the endpoint. In this case, I'll need to go through the portal where I created the Cognitive Services Lewis. I'll go to the resource. And here, if I go to keys and endpoints, it will show me a key and an endpoint. So let's copy this one, copy the key, put it in here. Oh. Copying the endpoint, and then pasting it in here. So I now have the application ID, I have the Lewis key, and I have the Lewis endpoint. Okay. Now I can run the cell because it has everything it needs. And let's test our trained language understanding model. So here we are. And now I can enter a command. So I can type turn on the light. And it will turn the light on. I can also type turn off the light. And then the light is off. So again, by training a language understanding model, I can now use that algorithm, use what I trained somewhere else. So we trained it in the Lewis.ai by giving it some utterances, some intents, etc. And now in a different notebook, and this is just a notebook where I'm running a little bit of code where I'm using that what I've trained, because I gave it the information it needed, so the application ID, the key, and the endpoint. But you could use it in an application or maybe an app on your mobile phone, anywhere you want. You could use this now. So that's really the power, and it's really easy to create such things. Easy to create a language understanding model. Now, there is also something that we could do is we could add voice control to this. So we can add a cognitive services, and I'm going to create a new one here. So let me create I'm going to paste it in here. I'm going to create a cognitive services. Okay, created it. And now I'm going to select, of course, West Europe again. I'm going to give it a name. So let's call it AI Fundamentals Cognitive Services. Let's see if that's still available. It is. Pricing tier, I'll choose the standard. I have understood the notice, and I'll click create. So that will now create my cognitive services. Let me quickly go back to the exercise here. So I have created that, and now I get the key and endpoint for my cognitive services resource. So I go back to the portal. I go towards the resource. And here on the left side, in this panel, I see keys and endpoint. I click on that, and I'll see again my key and endpoint. So I'll copy this, copy the key, go back to the exercise, paste the key in this box of code right here. I'll go towards the portal again, copy the endpoint, I'll tab towards the exercise again. Okay, pasting in the endpoint, and then the only thing that's still there is my region where I have my cognitive services in. And as you already knew this, my location is West Europe. So I'll copy that and I'll paste it in as well, West Europe. Okay, I'll press run. Ready to use cognitive services in West Europe. Okay, well, that's great. So I've added the cognitive services. I already have my trained language understanding model. I'll run this, but it's already there. So it's just for you to see. Oh, it's actually downloading it again. Okay, and it's now installed this custom Python package for cognitive services. So we can use it in this notebook. If you're not familiar with the programming language Python, don't worry, it's not required for this course. Now, again, we have a little box of code here that's going to use an audio file and interpret the audio file and then use it on the language understanding model. So the audio file is turn the light on. And it will recognize this and then actually turn the light on. And if you're done with that, I would advise you to go through the other exercises as well. We have an exercise around text analytics, speech, and translation. So really dive into this natural language processing. That brings us to the end of this module. So what did we do? We looked at an introduction of natural language processing, what it is and what it is in Azure. We looked at cognitive services and the text analytics, speech recognition, translation, and language understanding. With that, let's move on to Module 5. And in this module, we're going to talk about conversational AI. What is conversational AI? And we're going to look at responsible AI guidelines. Remember, folks, when we talked about this in Module 1, responsible AI, well, this also holds for bots, and I think it's an important topic. After that, we're going to look at the services in Azure, the Q&A maker, and the Azure bot service. But before we dive into that, let's start with conversational AI concepts. Because again, what is conversational AI? Well, conversational AI, builds on other AI workloads, in particular natural language processing, but also a bit of machine learning and sometimes also computer vision. And in general, when people use the term conversational AI, they're referring to bots. About bots, often people associate the term bot with something like an interface on a website, but it's much more, right? It can be on an email, social media, telephone, and many more examples. And it can also be used in a wide variety of different scenarios, like customer support, right? When asking frequently asked questions, instead of having a resource dedicated to answer those, you could use a bot. So it saves some resources. And of course, if it's a more complicated question, you can always hand it off to a human customer service representative. Another example would be system reservations, cinema tickets, flights, or a table at your favorite restaurant. Digital assistants, right? The voice assistant for in-home, online ordering, your favorite pizza, you can use a bot to order that. But there are also some other types of examples like healthcare, providing an automatic diagnosis based on systems, or office productivity, right? If you're you work in a large company, you have all these resources, all these corporate resources, and you could use a bot help you find those relevant resources that you, for instance, need for a particular task. And there are many more examples. So let's take a look at responsible AI. And I've listed here nine guidelines. So the first is be transparent about the bot, what the bot can and can do. And I think you should develop metrics to assess user satisfaction. Metrics for your bot should cover not only whether the user feels that the bot served its intended purpose, but also the user's sense of well-being and comfort while using the bot. The second point here is make it clear that the user is communicating with a bot, because it should be apparent to the user that they're not having an interaction with another person. And it's also important that it shows how the bot can help and the limitations associated with its use. The third point here is enable the bot to seamlessly hand off to a human if necessary. Yeah, because you should respect individual engagement preferences. If someone wants to talk to a human instead of a bot, well, that should be respected. Ensure the bot respects cultural norms. And to do that, you can limit the service area for norm violations where possible, and where appropriate, point to a relevant code of conduct for users. You could even apply machine learning techniques and keyword filtering mechanisms to enable your bot to detect, and even critically respond appropriately to sensitive or offensive input from users. Ensure the bot is reliable. And to do that, you can establish reliability metrics. And of course, you should review those periodically and consider what questions your bot needs to answer and rigorously test its performance and ongoing effectiveness. Respect user privacy. And one way to do this is you could inform users upfront about the data that you collect and how it is used, and you can obtain their consent beforehand. And number 7 is handle data securely, because users have every right to expect that their data will be handled securely, right? And you should follow security best practices that are appropriate for the type of data that your bot will be handling. There's, of course, a difference between sensitive and insensitive data, and if the data is personal or not. Ensure the bot meets accessible standards. Bots can benefit everyone, but only if they are designed to be inclusive and accessible to people of all abilities. 9, assume accountability for the bot's action. Developers are accountable for the bots they develop. You as a developer, if you are a developer, you are accountable. Okay, so those are the responsible AI guidelines. And with that, let's go to a small demo here. Let me just copy the link here, and then I'm gonna paste the link in here, and it will take me to this health bot. You can try it out yourself at home by following the same link. Let's scroll down here. You can see Microsoft Health Bot. And if I scroll down here, you can click on try a demo of an example end user experience. So I'm going to click on this, and then it will open the chat, and it will open an introduction of the Contoso Health bot. Now, the first thing you see is you see that it's already making sure that the user knows that it is a bot. It shows you what it can and cannot do, and it's being transparent. Okay. And at the bottom you can see already, you can ask me things like my arm hurts, info about diabetes. Well, and during this course we had some examples of diabetes. So can I have some info on diabetes? Okay, and there it is. I get an overview: diabetes mellitus. Occurs when a person's body can't make enough insulin. Okay, and I can click further on this by symptoms or causes. Okay. Well, if I'm satisfied with that, let's do something else. So let's say I have a cold, so my throat. Oh, is it like this? My throat hurts. So it registers the following symptoms, and they're reporting. I can report additional symptoms. Maybe I have a cough. I have a cough. Okay, so sore throat and a cough are registered symptoms. No, there aren't any other symptoms, so I'm going to type none, and now it's starting to assess my symptoms. So how long have I had a cough? Less than 3 weeks. How would you describe your cough? Well, it's a bit of a dry cough. So yeah, dry cough. Okay, submit it. You could see I could also leave it open by not ticking any of those boxes. Have you been diagnosed with asthma? No, I have not. Do you have a fever? No. Does your throat or nose feel itchy or tingly? Let's say yes. And I think this might be because it's asking for instance, allergies. I would assume, at least. Do you have a runny nose? Yeah, okay, let's do that as well. So here's what I said. There's an overview: 33 years, male, initial complaints, sore throat and cough, and then it collects some other symptoms. The suggested self-care is self-care at home, and it's possible causes could be common cold, flu, acute sinusitis, and hay fever. And I expected, based on the questions it asked me, I thought it was also trying to find out if it might be a case of hay fever. So really a health bot you can use to reduce the needed resources to get a diagnosis, and this information then can for instance be sent to a doctor. With that, let's head back to the slides. So that was an example of a bot, and let's continue with our second lesson, which is conversational AI in Azure. And remember, I talked about, I mentioned already two services, which was the Q&A maker and the Azure bot service. And the Q&A maker it's a cognitive service that enables you to define a knowledge base of questions and answer pairs, and you can create the knowledge base by answering questions and answers, or you can import an existing FAQ, frequently asked questions list. And you can also augment those questions and answers with some built-in chat sources, which include some common conversational exchange, like how are you doing, how is the weather. So you can augment the Q&A. And after creating the knowledge base, you train a model based on those questions and answers and publish it as a service. And then client applications, and in particular bots, can then consume the knowledge base and use it to determine appropriate responses to user input. So that's the Q&A maker service. And the Azure bot service, that provides a platform for creating, deploying, and managing bots. And with the service, developers can use the Microsoft Bot Framework SDK to develop bots easy and also easily deploy and manage them in Azure. Also, by using the Azure bot service, you can easily integrate your bot with, for instance, Azure Cognitive Service like Lewis and Q&A Maker, and connect your bot to multiple channels such as web chat, email, or even Microsoft Teams. So those are the two services, and with that, let's now just go and create a bot. So in this exercise, we're going to create a bot. Let me just tab into my Azure Machine Learning Workspace. I'll go to the notebooks right here, and there I will scroll down. I will scroll down to go to the Q&A bot notebook. Here we are at the Conversational AI notebook. I'll scroll down because in this exercise we're going to do a couple of things. We're going to first of all create a Q&A, make a knowledge base. We're going to create the Azure resources that we'll need with it, and from there on we'll continue, creating everything. Okay, so first of all, I'll need to go to qnamaker.ai. So let me just press a right click here, open a new tab. Do not normally click on it, otherwise you'll lose here, and it will need to reload, which will just take a couple of seconds. So that's something you want to avoid. So it's opening a new tab here in the qnamaker.ai. Now I can click here at the top, create a knowledge base, and this will give me a multi-step setup to create a knowledge base. First of all, I'll need to create a Q&A service in Microsoft Azure. So if I click this, here we are in the create for the Q&A Maker. You can see it in the top left, Q&A Maker. I have the Azure internal subscription again selected, internal consumption, and I'll check my AI Fundamentals resource group. I'll enter a name, so that is the AI Fundamentals Q&A. Let's see if that's already taken. Nope, it's okay. Pricing tier. I will do the standard tier here, since I might have been using the free tier somewhere else already. Okay, now my search location, I'm going to pick West Europe. Again, for you, just take I think you can take the free here as well. The app name, I'll leave that as it is, and we'll again choose West Europe for the website's location. I'll disable application insights. That's not something we're going to look at right now. And that's it. So let's verify if it's all correct. And click on create. So now, if everything is in order, if I didn't specify things wrong, it now starts deploying the Cognitive Services Q&A Maker. Now, this will take a minute. So meanwhile, let's go back to the exercise. So let's go back to the Q&A Maker here. And as soon as it has been created in Azure, we'll need to hit the refresh button. So I'll hit the refresh button. I'll again select the Azure internal subscription and choose the AI Fundamentals Q&A. And I can select the language, which of course I am going for English. Okay. Next up, we're going to name my knowledge base and we're going to populate the knowledge base. So let me just check the exercise here. What kind of name does it want me to choose? So it says Margie's Travel Knowledge Base. Okay, so let's paste it in there. And now it needs some information. I can do all the knowledge base, I can create it manually. But in this case, we are going to use a URL. Which is the URL? It's from the GitHub. Let's write this one. I'll copy this right here. Which is basically a document, a Word document with just some questions and answers. So let me copy this right away and paste the link in here. And then don't forget to click the add button here. So now it is added. Also, just for you here, let me just open it right away. And now you can see that it opens a Margie's frequently asked questions.docx. Let me open that just to show you what's in there. And here you are, just some really basic questions and answers. That's it. Okay, let's minimize that again. And let's go back to here. So populate, yes, we've added the URL. Chit chat, let's take professional, but you can also, of course, choose something else. So I'm going to click the button. Will not take very long, but here it will create it. And after this is created, we can start creating a actual bot that then uses the question and answer pairs that were in the document, and that uses it through the Q&A maker. So while this is being created, let's quickly continue on. Oh, it's actually already done. But let's quickly go back here and see what else is there to do. Right, so we need to add a Q&A pair. So there are already a couple in there, but we're going to do some others, and then we're going to save and train and test it. Okay. So let me just add a pair. On the right here, I can see add Q&A pair. I'll click on this, so I can just add anything I like. So how is the weather? I could answer something. I could say something like this, and then it's great. Okay, now I can save and train. Again, it only takes a minute because we don't have a lot of questions and answers, so it's quite easy to train, and then I can test it. Here I can say, how is the weather? And then it will answer me, it is great, etc. Very simple. I could also say something else. Why Margie's travel? And it will give me these things. Okay, so it works. Let's remove this, let's close this. And we have now a trained algorithm and combined with our knowledge base. So let me just go here. I'm going to click on publish. Yeah, sure. Of course, publish. Now this will take a minute, but now it creates an endpoint, so we can use that inside our bot, which is great. And now we can test it inside the portal as soon as it's there. Okay, so it's created, and there's some general information here, and we're gonna create bot here. Click this. Which will open a new, an Azure resource that we can create. Some of the information will already be filled in, and we're gonna just finish it up. So I'm gonna leave as much as the defaults here as possible. I'm not gonna turn application insights on, but I think everything else is correct. So let's just create here, validate the information, and it starts creating the bot. Now, while this is creating, let me just go back here to the exercise. As soon as the bot is created, we can test it. So we can use the test in web chat, which we'll do as well. And then we can go and in the channels page, and we can use the code provided there to actually use the bot inside, for instance, an application, which we're simulating here. Okay. So while this is being created, you can see that it's probably almost done. Here we go. It is done. I'll go to resource. And here I have a couple of things on the left panel that I can do. So test in web chat. And here we have, again, like a box where I can type at the bottom, I can type a message just to test, if this bot is working. So let me just test something here. So how is the weather? There it is. So normally I would wait for the hello and welcome, and then you know that it's working. So I can also say why Margie's travel. And then it will immediately now, see, it has started up now. So now it's a lot faster with providing me an answer. Okay, Now I can also go to channels, as you should do as well in the exercise. If I click on this, which opens up a web chat, and I can click the edit button right here. Now, here it gives me some key and some embedded code. So let's take a look at what we need in the exercise. Because again, we're going to paste some of the information again in a block of code so we can run it. Okay? So if we're here, access the bot through a channel, and we're gonna, in the web chat, we're gonna edit, and then we're gonna take the HTML embedded code. I'll show you this. And we'll paste this instead of the embed code goes here, which is actually here in the code below. So I'm going to the fundamentals bot and the embedded code. I'm gonna click the copy button. I'm almost clicking a double just to make sure. Okay. And then I'll select this line and I'll paste it. Okay. Now, two things. This creates an iframe for developers out there who know this is just a frame. Just see it as a frame. And it's a little bit big. So what we're going to do is we're going to change the minimum height. Instead of 500, we're going to set it to 200, so it's a little bit smaller. As well as you can see here, basically what it does, it creates a frame and then calls the bot, but it's missing one piece of authentication. It's missing a secret, and that's why here you can see the words "your secret" here, and I'll need to replace those with the actual secret. So I'm going to click here. I'm going to click here. And I'm gonna see one of these keys, copy it, paste it right in there, and then I can just start running this code. So again, it creates an iframe, which is like a frame in a frame. And here you can also see that my chat window and my bot is now up and running right here in this notebook. So I can say something like, hello. And after it has connected, it says hello and welcome, and it answers me. So originally I have to wait, of course, for the hello and welcome, but I'm always like a little bit hasty. So I can say, why Margie? And then it will answer me. So now it gives you don't really need to type the exact sentence, right? You can play with it, and it's intelligent enough to recognize what you're actually what do you want to know. Okay, and that actually brings us to the end of the Q&A bot exercise. And that brings us to the end of this course. So let's do a little recap. What have we discussed today? We did 5 modules in total, and we started up with artificial intelligence. What is artificial intelligence? We looked at a definition of artificial intelligence. And in the second part of that module, we looked at responsible AI. Remember the challenges and risks around AI and the 6 principles that we as Microsoft adhere to when we are developing AI solutions. Next up, we talked about machine learning. These 3 broad, these types of algorithms, right? Regression, clustering, and classification. Regression, I used the bike rental, predicting how many bikes I would rent out. For classification, whether a person does or does not have diabetes. And the clustering algorithm, we found groups in a data about flowers, and we used the length of a flower and the number of petals. Then we moved on to the first of these 3 broad topics, right? Computer vision. And we talked about what is computer vision and how do you extract information from a picture. And then we went into the services on Azure, the cognitive services, of course, image analysis, getting a description from a picture. We trained a model. Remember the bananas, oranges, and apples. Thank you. And analyzing faces, form recognizer surface, reading text. We all looked at that in computer vision. And then in our 4th module, we looked at natural language processing, where first we discussed a little bit the word natural, because we have language processing in the form of a programming language like Python, but our own language is less precise. There's typos or there's wordplay in it, and a programming language cannot have that. So we did that, and we talked about these 4 broad topics like text analysis, speech recognition, translation, and language understanding. And then we went into our final module, conversational AI, right? We talked about the Q&A maker, we talked about the Azure bot service, and at the start we talked about responsible AI guidelines for bots. And as a demo, I showed you around, I showed you a knowledge base and how easy it is to create it or to modify it. And then we had a bot, and we had our chatbot completely ready in the notebook. We played around with it, and you saw how easy it was. Now, there are still some remaining exercises for you to do, and I would really, really, really recommend you to do them. Okay, so that brings us to the end of the day. Thank you for attending this session. And again, there's more ways to learn, right? You can continue on your learning Azure journey. You can go to MS Learn. There are a lot of self-paced offerings there, completely free, and you can just keep on learning right there. Yeah, that's about it. So I really hope you enjoyed today. I wish you good luck on the exam, and happy studying for it.
you.